Hello, dear students. In the last period, we have studied about the first order reaction, and for the first order reaction, we have derived this equation that the rate constant K is equal to 2.03 by T log of R0 by R, or we can say that T is equal to 2.303 by K log of R0 by R, where R0 is the initial concentration of reactant and R is the final concentration of reactants. Now suppose the reaction is R, that is reactant, that gives the products. When you have T is equal to 0, that is the initial time, your R is 0 is equal to A. Let us say it is A mole per liter and product has not been yet produced, so the concentration is 0. Now in the time T, like T is equal to T time, so in meanwhile the T time passes and A is utilized X. So X amount of product has been formed. So when T is equal to T, your R, that is the final concentration of reactant, is equal to A minus X, and the product formed is X. It means that X is the concentration of R that is used in the time T. So we can write that R0 is equal to A and R is equal to A minus X. So this same equation, T is equal to 2.303 by K log of R0 by R, instead of R0 we write A, instead of R we write A minus X, and we finally get this equation. T is equal to 2.303 by K log of A divided by A minus X. Now again we will move towards the half-life time T1 half. It is the time required to convert the initial concentration of reactants to half of its initial concentration. So for T1 half, or for half-life time definition, we can write that the final concentration R is equal to R by 2 when you have T is equal to T1 half. So let us put the value into the equation. Let us put the same value into the equation. T is equal to 2.303 K log of R0 by R. Now instead of T, we will write T1 half. Instead of R, we will write R by R0 by 2. So we can write T1 half is equal to 2.303 by K log of R0 divided by R0 by 2. This R0 get cancelled and we get 2, denominator of denominator, that turns into numerator. So we get log of 2. So T1 half is equal to 2.303 K into log of T. This log of 2 has value 0.3010. So T1 half is equal to 2.303 multiplied by, this is 303 we can write, multiplied by 0.3010 divided by K, and ultimately we get T1 half is equal to 0.693 upon K. The multiplication of 2.303 into 0.3010 is 0.693. Please remember this if you can. It will be, or it is going to be very helpful. The above equation is the equation for calculating the half-life time for first order reaction. Here we can see that there is no concentration term available in this equation. So half-life time of first order reaction is independent of the any concentration term, and half-life time of first order reaction is inversely proportional to the rate constant of the reaction. So this is what it is I have written into the words here. You can easily understand it. So my dear students, whatever we have studied about the integrated law, let us revise it. First, when we write the differential rate law, we can write for zero order reaction dr by dt is equal to minus k to the power r0, that is minus k. For first order reaction, we can write dr by dt is equal to minus k into r to the power 1, or simply kr. The straight line plot that we have seen, that the straight line plot for zero order reaction, we draw it for r versus t, and for first order reaction we draw it for ln r versus t, or log r versus t. Half-life time, if we think, then the half-life time for zero order reaction T1 half is equal to R0 by 2K, and half-life time for first order reaction T1 half is equal to 0.693 upon K. So this is what we understand about the reaction. Note that 0.693 is equal to 2.303 multiplied by 0.3010, that is 2.303. This is the value of log 2. This 2.03 we write to convert it into ln, log to convert ln. So we can say that your 0.693 is nothing but ln 2. Please remember this. Now we want to understand about unit of K. So for zero order reaction, the unit of K is mole per liter per second, or we can say that it is concentration per time. And for first order reaction, the unit is second inverse, or we can say that it is time inverse. So this is what we have revised everything about it, and now we are going to go for the related numericals. So let's first think of the numericals. The initial concentration of N2O5 in the following first order reaction, N2O5 gas, that gives 2 NO2 gas plus 1 by 2 O2 gas, was 1.24 into 10 to the power minus 2 mole per liter at 318 Kelvin. The concentration of N2O5 after 60 minutes was 0.20 into 10 to the power minus 2 mole per liter. Calculate the rate constant of the reaction at 318 Kelvin. So let us see what data is given here. Order of the reaction, that is the first order reaction. Your initial concentration N2050 or your R0 is equal to 1.24 into 10 to the power minus 2 mole per liter. Your T is equal to 60 minutes. Your N2O5 or your R is equal to 0.2 into 10 to the power minus 2 mole per liter. Now we want to find out K. So we write the equation for K. K is equal to 2.303 by T log of R0 by R. We put the value of T is equal to 60 minutes. We put R0 is equal to 1.24 into 10 to the power minus 2. We put R is equal to 0.2 into 10 to the power minus 2. As this 1.24 is divided by 0.2, we get 6.2 as an answer. So 2.303 by 60 log of 6.2. If we look into the log tables and find out the log of 6.2, we can get 0.7924. So we just multiplied 2.303 divided by 60 with 0.7924, and finally we get 0.0304 minute inverse. Here the minute inverse represents that the reaction is of first order. So this is how we can understand about the numericals. We will calculate more, or we will discuss more numericals in the next video. Happy learning.